Going once, twice, thrice. Okay, so up next, the way I'd like to proceed is basically to have a bit of a showcase or demonstration of some of the work that's been going on with KubeFlow that came out of the KubeCon conference recently. Some folks at Red Hat have been working to get it up and running on OpenShift. And I've asked William Benton to do a brief introduction for those who aren't aware of what it is and what the relevance is for us, and then Subin to take us through a demo of what he's been able to get going on OpenShift so far. So with that, William, over to you. Sorry, Will, over to you.
All right, I'm just sharing the screen here. Let me know when you can see it.
Not quite yet. There it comes. All right.
All right, so I'd like to start with just a little bit of context on why it's hard to operationalize machine learning in applications. And we're thinking about intelligent applications that learn from data to become better the more people use them to provide improved functionality. And if you think about what these applications look like, they look a lot like contemporary applications, except that they're also dealing with data. They're training predictive models based on that data, and they're maybe dealing with a wider range of data sources than a conventional database-backed web application. So all of the things you have to deal with in a conventional application still apply, except instead of just scaling out say maybe a web proxy or duplicating or replicating a SQL database, you might have to scale out a compute framework as well to provide the sort of performance guarantees that your users expect. Now, the intelligent components in this application are typically going to be prototyped by data scientists, and data scientists like to work in notebooks. These are going to be turned into apps by machine learning engineers or app developers. And if we put it another way, we see one of the big problems with turning machine learning into a production application. These data scientists are working in one environment, handing it off to another team that's then going to sort of port it over to work in another environment. And I bet those of you who work with data scientists or who are data scientists have been in a position in the past to get a notebook from a colleague that either doesn't run or doesn't produce the same results that your colleague expects. And I can say this because I've gotten those notebooks from colleagues, and I think I've also given those notebooks to colleagues. Another problem with operationalizing these machine learning frameworks is that they might depend on specialized libraries, frameworks that not everyone is going to have installed, frameworks that aren't going to be packaged to be easy to distribute. They might depend on specialized hardware drivers as well to accelerate learning problems. Another problem, in addition to the monitoring and scale challenges you have with conventional apps, is that intelligent apps also need to monitor the performance of models. As you know, a trained model captures something about the data it was trained on. But if new data drifts from the training data, we can get silent failures. So we need to have some way to monitor the performance of our models in addition to the performance of our application. Now, OpenShift can make some of this easier by providing a really nice workflow for reproducible builds and reproducible deployments from a Git repository through a source to image builder. And you can basically ensure that if you use your notebooks with a source to image pipeline, that your colleagues will be able to reproduce them and run them on OpenShift in the cloud. But the problem is you still don't get past the issue of having a common library of these frameworks that are packaged. So we'll talk a little bit more about that in a second, but I want to introduce KubeFlow at this point. And the idea for KubeFlow is to sort of do for machine learning frameworks on Kubernetes what Kubernetes does for application orchestration in general. The idea is that we have custom resource definitions for Jupyter Hub so that you can have a multi-user collaborative notebook, TensorFlow so that you can train conventional or deep learning models, and TensorFlow serving so that you can actually deploy those models as components of a production application. KubeFlow is a new project that was founded at Google. It was just announced last month at KubeCon, but it's already attracted a ton of excitement and attention. And the promise of KubeFlow is really that all of these frameworks and some of the hardware drivers that you need to actually deploy these frameworks and get good performance are going to be packaged up so that you can run them either on your laptop in a local Kubernetes cluster or in the cloud at scale. So if you've been following machine learning on OpenShift for some time, you might have heard of efforts like radanalytics.io, which a number of people on this call are involved with, or the PSAP program. And the really nice thing about KubeFlow is another spin on these approaches. So KubeFlow uses custom resource definitions, which weren't available when we started working on radanalytics.io. And it's another way to get this sort of capability into Kubernetes and OpenShift. So we're really excited that more people are interested in machine learning on Kubernetes and OpenShift. And we're involved in this community, and we're looking at how we can take the work that's already been done and integrate it and benefit from the KubeFlow community as well. So with that, I'll hand it back over to Matt.
Hey, thanks, Will. So next up, we'll have Subin do a demonstration of what he's got working right now for KubeFlow and OpenShift, and then I'd like to open it up for some discussion, some feedback, people's thoughts. So Subin, over to you.
We're seeing OpenShift commands, get nodes, etc.
Great. Okay, so what I have is a setup with a GPU on a single OpenShift cluster. So I have a single node in this OpenShift cluster, and I have a GPU, NVIDIA GPU in this cluster. So I really wanted to show a demo of one of the component of KubeFlow, which is the TF TensorFlow job operator, and show you a demo of an application doing the training on the GPU, saving the model into a volume, and doing TensorFlow serving from that particular volume. But unfortunately, some bug, and I'm not able to do that. So I'll do a very reduced demo of what we have working for a TensorFlow job operator. So just to I have made notes just to share with everyone. But here, what I'm going to do is that I'm going to create just 1 second. Just let me see if there's okay. So this demo and the commands which you see here is to create a TensorFlow job operator from the templates. Right now, if you look at the KubeFlow code base, you have the KSNet commands to create the different components of KubeFlow. I'm just going to create this particular one component, but not using KSNet, but using the manifest files, which was given by KSNet command. And the first thing is that I'm just going to create a new project within OpenShift called test. And let me just see if the test has been created. And then what I will do is I'm going to log in as a cluster admin and create a default admin role binding so that my CRDs and CRD instances can be created. And then I will go ahead and create a TF job operator template. So you can see here that I have a KubeFlow operator template available here. And this is all very similar to what you find on the KubeFlow GitHub project. And then I will go ahead and create an application of KubeFlow operator. And you can see that it will create a config map called TF job operator config. It will create a deployment config. Get pod. It will create a job operator pod in OpenShift. So coming back to OpenShift, so you can see here that I have the job operator pod, and if I look at the logs, I should be able to see that the controller has started properly. And what I'm going to do next is to submit a CRD instance, which is a TF job. So when you submit a TF job, this is how the template would look. You need to pass in an image, give in the replica spec, and you can or you cannot, provided if you have GPU, provide the NVIDIA GPU resource limits. And if you don't have a GPU, you don't need to pass this. But if you have a GPU, just pass this so that the GPU is allocated to this particular pod. So I have with me some templates for distributed job. This is a TF job for distributed application, doing really nothing much, just as a master worker and the default parameter server. And I have another instance of sample job, which is just having the image, which is just doing a matrix multiplication inside. So I will go ahead and I will just create a job. Create. So if you notice that when I create the job, it says that the user Subin cannot create the job. So I need to again go back and log in as a cluster admin. Log in as a cluster admin, and then when I submit this job, you can see that a sample job has been created. If we get TF job, will show you that a sample job has been created. This is a CRD instance. And when I come back to OpenShift, I can see in the operator logs that that particular job has been submitted and the operator is creating the pods. And if I look at the available pods here, I can see that a sample TF job pod has started and that has already completed. If I go to that particular pod and look at the logs, I can see the matrix multiplication output shown here. I also have another job which is MNIST example. If I submit that, MNIST, yeah. So, and if I look at the available list of jobs, I can see that there are two jobs which have been submitted. One is the MNIST and the sample TF job. Again, coming back to the job operator and looking at the logs, I can find that that particular job has been submitted, and you can see that the MNIST status is shown here. It's currently running here. And again, going back to the pods, I can see that the MNIST master, the pod has started and it's running right now. I'm going to give it a few seconds so that it can complete. It's going to take some time. Well, the MNIST job is taking a little bit more time. I think it's related to the computations involved in it. So that's about it for my demo to show one of the components of KubeFlow, which is the TF job operator working on OpenShift. It is internally using a service account, which is having the cluster admin privileges. That's how it works. Thank you so much.